organizers of the KW Big Data peer-to-peer group. Lou back there waving her hand is another organizer, as is Kevin over here. Thanks everybody for coming out tonight. So we're here tonight to hear from Dexter Fitchuk. Dexter works at TD Labs out of the Communitech location. And he's full-time with as an applied machine learning developer with the Innovation Lab. So he holds a Bachelor of Science in Computer Science with a focus in natural language processing from Trent. And he's currently studying part-time for his master's in computer vision. So that's exciting. Wonderful. So thank you so much. You're going to talk to us all about machine learning in a lab.
Yeah,
all right.
exactly.
Thanks, Dexter.
Talk will be kind of like a weird variety of the process side of how we explore machine learning in our space, and then a little bit on the tooling that we use. And I wanted to leave a big chunk just for mostly question and answers. I don't like just talking at people, so I find that to be a lot more engaging. So as Aaron said, I work in TD Bank's Innovation Lab in the other Communitech office. So the lab, a little bit of the history, has been there for about 3 years, maybe 4 years. And it started basically with just 3 employees. Now we're at 15 employees full-time, and then we have about 10 to 15 co-ops per term. I'm the only dev that we have that currently focuses on machine learning in all of our stuff. So traditionally we focus on customer experiences and looking at basically pain points within the bank as a whole and seeing what are new experiences that we could introduce that basically solve these problems. So a lot of what we do is we'll start with like a hackathon with all of our students around a problem, see whatever crazy thing that they build, we don't give any input. We then take those solutions, we'll kind of cherry pick which actually makes sense. Students can get a little bizarre with their creations, so we really have to kind of guide it a little bit. But we'll take these things and we'll basically just mock them up in Sketch and Envision so we can have like a concept app. We'll go in the community, get some feedback, we'll basically just do interviews with different people. And from that feedback, we'll then take it back and try to build a more complete concept. And then we'll normally find like a stakeholder in the bank to work with. I don't want to bore you guys with too much of that process, but the big thing of what we do is we really do this iterative process where we get feedback. Now, where the machine learning comes in is really cool, where instead of having like a space that's just dedicated only to machine learning, I get to kind of look at all of our projects that we currently have going and see where does it make sense to maybe explore using machine learning. There's lots of times I sit there and try to think of what's a cool machine learning project we could do, and it's a lot more natural to look at what we are doing and see where we could start enhancing it and really doing things outside of the box. So that's a little bit of an introduction to the lab and myself. So basically, I might have just covered some of this. So there's kind of, if I split up what I like do with the machine learning in our space, there's kind of 3 different streams. So find ways that machine learning can influence the customer experience. So it could be a new experience, it could be improving an existing one. It's kind of a mix of like, I always look at what Google's doing and try to apply those same principles to us because they're so great at really bringing you the best experience. And then if any of you watched Google I/O, which I'm sure a lot of you did, you saw just everything had machine learning peppered in it. So at TD we're a little bit slower than that, but I'm trying to find all these cool ways we can start applying it. The other cool thing that I get to do is test and validate new software publications and methods that come out. So I am on Reddit reading the machine learning thread, seeing what people are talking about. I get to look at GitHub and the top trending repos to see kind of software that's really new and unique. Because we're kind of outside of the TD network, even though we're employees, we get to play with a lot more different tools and basically try to push them to the extremes and really see what they're capable of. And by doing this, we then get to trickle back kind of, if technology is valuable, recommend it to other teams in the organization and do a lot more exploration that in a large company you don't always get to do. And then the last thing is really exploring capabilities of what machine learning can and can't do. So I was talking with Kevin before too, is there's a lot of companies out there that just throw machine learning in whatever they're doing just to have that word association with it. But really what I try to do is genuine machine learning. So where it makes sense to apply machine learning, we'll actually apply it. Where it doesn't make sense, sometimes an algorithm can just be 3 if statements. It doesn't need to be complicated. Not trying to just push machine learning on everything that we do. And then by doing this, I found that we're really able to find small, unique areas that might not seem the most impactful and might just be a new way of suggesting who you send money to, but that could actually have a big impact for a lot of people if it's just removing a few extra steps, instead of not everything's going to be this big, life-changing machine learning project. So it's kind of cool. Google's been I really follow Google a lot in this space. So they've been talking a lot about human-centered machine learning. And in our space, because we focus so much on experiences, that's obviously a lot of what we do. So besides just myself being familiar with machine learning and our students that we work with directly are like data science students, we need to have this kind of human-centered AI. So I don't always know the greatest decisions for design or how we should present things. And this really means that we need to involve engineers and designers and everyone on the team with machine learning. They should be familiar with kind of high-level concepts we've found. They don't have to know algorithms or anything like that, but they should understand kind of the principles of machine learning, what kind of data TD would have, what kind of things we could do, what kind of things you could predict, and kind of have that creative outsider component of it. And by having designers and engineers that also have a high-level understanding of machine learning, you can start to have real interesting conversations, especially when doing different research. A designer will have a very different perspective than an engineer will or a data scientist will. So by having all these diverse backgrounds, you really can come up with new, unique ideas that if it's just a team of data scientists, you don't always get. So then the other thing is that a lot of our products that are already existing, we can really reshape with machine learning. So sometimes we'll look at things that TD already has and kind of re-explore. In today's world, some of our apps haven't been updated in like 5 years, so we'll try to see what are things that we actually could completely revamp and look at a whole new experience around that now has been enabled by machine learning. So the big thing is all the services that we have will eventually be transformed, but it's a matter of finding ways to augment experiences instead of just replacing them. So if we can enhance, I'm saying enhancement a lot, but the big thing is enhancing and not thinking that we'll just replace everything that's already there. And then the big thing, again, plenty of products can feel smart or personal without machine learning. It's really easy to get pulled in and think that a ton of ideas are only possible with machine learning. So one of them that I've heard is, what if we could predict when you have to pay your bill? We've seen you pay it a ton over time, and we could almost predict that in the future. We also found that if you just look at the average day that you pay it every month, and then just maybe 1 or 2 days before that average day, do the same prompt, we don't have to do any machine learning, and we're already doing something that might be more accurate. It's not a black box. We can already explain what it does. So there's not always a need for machine learning in every single thing that we do. Sometimes it's just making smarter decisions. So this is, if any of you deal with different stakeholders in your organization, or sometimes different people from business backgrounds or things like that, you'll get a lot of really bizarre requests for AI, thinking that it will basically fix every problem for you, or you can put it on everything. And the other big thing I really get all the time is people say they want AI and machine learning, and it's always they just want like a dashboard. They just want a cool chart to see their data, or they think if you just put it in an algorithm, it will just give you the answers. You'll just get these insights like suddenly, oh, these customers aren't coming here for this reason, or you're losing this many customers because of this. All of that looking between the lines is a lot more analysis of your data, and it does not have to do with machine learning. So a big thing in our space is making sure that we're really clear with everyone on what you can and can't do with machine learning, and sometimes it is just displaying data in a nicer way. So we'll build a dashboard, but we do not try to sugarcoat it and say that's AI. And yeah, some ideas will be extremely bizarre that we do in our space. I've been trying to pitch an autonomous car exploration for a really long time. We still aren't doing it yet, but sometimes when I can find a really bizarre reason we should, there might be really cool things TD could look at, like insurance options in an autonomous vehicle world and things like that. But sometimes things are really intuitive, and I think a lot of the things, I'll go back to Google, like with Gmail, it makes sense to totally, if you mention some sort of phrase like I've attached this thing, and then you haven't actually attached the file, it makes perfect sense to have a pop-up saying you actually haven't attached anything. Same with, they just added, in Gmail they're going to have sentence autocomplete, so we'll try to predict what you're going to say, and then you can tap to do the whole thing. These are things that when you hear them, it's really intuitive and it just makes sense to do. But it's really hard to think of those no-brainer solutions without having to do a lot of exploration. Some of my slides also might be kind of out of an order that isn't as coherent, but imagine this was at the beginning of the presentation, but basically why now are banks looking at machine learning in large companies? And everyone says that compute is cheaper, data, like storage is cheaper, data is more available. And a lot of that is true, but even like 10 years ago, data was already a lot cheaper than it was. Computing was pretty powerful back then, and all these machine learning algorithms that we're now leveraging are over 40 years old. So why is it now that banks and large organizations are really interested in this stuff? And I like to boil it down to these, well, two of these are cases, one is more evidence, but a lot of powerful software like TensorFlow, PyTorch, and even different Python libraries are becoming open source. So it's free for these companies to use, where normally we would just resort to IBM or Google Cloud, Microsoft, and use one of their APIs. We're now getting the tools that they actually use in-house that are made free and we can actually contribute to. So because there is now TensorFlow, we couldn't normally at TD code in-house GPU accelerated deep learning libraries just to use, because we're not skilled at that. That's not what our specialty is. But because this is being made accessible for teams to use, it actually makes it so we can start thinking of really new creative things, and basically what the Googles and Facebooks are doing and trying to adopt that into our space. So I'm going to jump to the third point. So data also continues to become more accessible within the bank. So this goes with every large organization, but mainframes were where everyone had data stored, and some of those systems still rely on mainframes. So as companies kind of are now in this era where we're changing all of our traditional architecture, we're moving stuff off of mainframes, and more data just in the world as a whole is becoming open and more accessible. So because the data has existed for a long time, but it's becoming more within reach, both internally in companies and externally, it makes it a lot more possible for what we can do. Going to the Google reference, they've always had it so whatever team that you're on, you have access to not like exact user metrics and stuff, but there's a cool pool of different places that you can actually pull data and associate it together. And by having that, you create basically new products that you wouldn't even think of before, because you can associate these tables and different data sources that normally could be very separate in an organization. And then right now, I think is really the prime time where machine learning everyone is talking about, but really we're starting to see apps truly use it. So this is like Google, Gmail, Photos, Apple putting GPUs, or not GPUs, but AI chips right on their phones. We're really starting to see that for customers. We're able to give them machine learning on the device. So even there's TensorFlow JS just came out, which is a client-side way of doing predictions. So normally you would have to have such a scalable like server in the back end to run whatever your model was, but now you can actually serve your model directly to whoever's viewing your web page's browser, and it will actually perform the prediction on their own system. So you can actually have almost a distributed machine learning thing where you don't have to have a server just to do your model. So some cool examples. So it's kind of weird for this, I wasn't allowed to talk about stuff we're currently working on, so I had to scour all of our TD examples that we've publicly said that we're working on, and then I'm allowed to talk about those ones. So the first one, probably when you hear bank and machine learning, is fraud detection. So it's actually really cool that fraud detection is still a problem, because you would think that, well, traditionally we've used logistic regression for it, and I think probably 80% of the world that still uses or is doing some sort of fraud detection is using logistic regression. But now with things such as deep learning, we've done a lot of work with variational autoencoders and looking at reconstructing and looking at the error between. Basically, a variational autoencoder will take input data and then it will compress it to a smaller latent space, and then it will try to reconstruct it. So it basically learns the really underlying patterns in data. But then basically, if you train that on something like fraud, you basically, when you reconstruct something that's your output target, you look at the error between your input and output. And if your model is having a really hard time, like a really high reconstruction error for some sort of input, it actually might mean that this data doesn't fit the pattern of what we've seen, and it actually could be a fraudulent thing. So it's kind of cool looking at these really new architectures and finding ways that we can leverage them in our space, because fraud will always keep happening. But it's cool to find the new tech that might change or might improve it. Another cool example is PayPal did some work that we've been following on, they call it, I think it's node to vec. So if any of you are familiar with word2vec, basically word2vec looks at the relationships between words in a sentence and then almost hashes out a vector where these vectors that are then similar are words that are similar. So you might have king and queen actually have these vectors that are really similar, but queen and woman would be similar, but king and woman wouldn't be similar because there isn't anything really similar. So PayPal's looking at the relationships between vendors or like customers and merchants, and then by looking at the sequence of transactions, they found that they had a lot of bad actors on both sides. So you'd have a customer account that a bad actor had and a merchant account a bad actor had, and that they'll actually spoof real transactions back and forth so that when you actually do a separate fraudulent one, it looks legitimate. But they basically put this model, sorry, I'm gonna go for a sip of water. Basically, when you look at the patterns and the sequence of these merchants to customers, they use this word2vec algorithm, and they actually were able to look at the bad actors and the vectors created for them and find new bad actor vectors in their network they didn't know existed, and actually proactively find these accounts that were undetected, no one even knew existed, just by putting it in this word2vec algorithm, creating this hashed value vector for it, and then finding similar ones to that. So there's always a lot of cool new things happening. Sadly, like I said, 80% of the world probably still relies on logistic regression for fraud detection, but it's cool seeing these really unique spaces for different domains pop up. So another really cool case, especially with NLP and then a lot of more voice data stuff happening, is analyzing call center data. So some ideas, I've even seen TD post articles about this, that you could analyze disgruntled customers or see if they're disgruntled. My opinion is most customers that call in are probably disgruntled. No one calls to tell us we're doing a good job. But a really cool thing that you could look at, just from what we've kind of talked about, is looking at call routing. So if you already had an agent right away, so this would be some sort of bot that basically you told your problem to, doing smarter call routing in a call center where you can actually over time see the agents that are a little bit more specialized. Maybe one's better at talking about your tax stuff and one might be better at talking about problems with your mortgage. Naturally, people specialize, so if you started routing calls directly to those agents based on the criteria, you could basically start improving the amount of time for a call, because if you have a new agent that's not as familiar with one area but is with another, it makes sense just to keep giving them ones for what's in their domain. And you can actually analyze over time what different people are talking about, then correlate that with the time of the call to kind of do this smarter call routing. So that's one thing we've talked about. Another would be if, this is like, I don't know, it's kind of a more bizarre one, but analyzing if someone acts like, or if you think someone will hang up in a call and predicting it maybe before, 20 or 30 seconds before based on the current dialogue, and then really changing your tone, or maybe you would need to say, oh, I'll get a manager for you right now, and really doing that next step, so trying to be proactive. I don't know what the perfect step is when you know if someone's going to hang up, but it's more being able to predict something like that based on the dialogue and tone, and then finding a way to intervene. So again, AI and machine learning won't find the way to intervene for you, but it can help you find the way to predict something like that. So this was the example I gave before, so prompting to pay bills. So the case of just like looking at the date you pay your bill, that's not a very unique thing. That you can just do the average day that you pay. But a cooler thing to actually look into is looking at when do people typically in your area pay bills for different vendors, looking at if it's over average. So that part's not machine learning. But then also looking at, even for e-transfers and things like that, actually pre-populating when you want to send money to someone. My roommates send me rent through an e-transfer, the same, it's a lot more flexible, a lot of them can be late, but having it right when you go to send an e-transfer, it can automatically pre-populate some cards with different people and maybe the amounts, and doing suggestions like that. So it's an area where you could do it without machine learning, but for things like rent and other expenses, some people do, we found, send money very sporadically, and it's not as easy to just look at the average of days or the average time they sent it every month. So something like that is kind of cool for adding machine learning, but you can also add a few more additional static rules on top of it to make sure you're not doing blind things. Like if we know you just paid your roommate rent, we wouldn't suggest something like that. And then this is a case that basically we've been talking about a lot, especially with layer 6 coming into TD, is proactively offering people mortgages, and this could be any service. So this is really when we're trying to be the bank that is looking out for you. So not always looking at when it's profitable for us or blindly offering to you when we should, or when we think when it might be more profitable to offer you a mortgage, but looking at your spending and looking at your habits and saying, hey, maybe now is a really good time for you to purchase a house, or maybe a car, and we could look at your different transit, because basically looking at people's transactions, you can get a lot from them. You could basically see when someone's taking the bus, or if they're having car problems, if they're constantly at Jiffy Lube or a dealer, and then being able to automatically offer maybe a pre-approved loan for a vehicle or something like that. So it's really kind of making more personalized experiences that are subtle, unique, but we're being proactive and really offering these services to you. So, and then over time, also suggesting better money management strategies. My opinion is that, I spelled strategies wrong, but my opinion is that a lot of the strategies we have are very like static, just like if you're coding an algorithm where it's a mortgage specialist or someone will actually have seen it over time in a lot of ways and think that they'll know best. But if you go and ask a few different people their opinion, you'll get very differing ones. So same with doing investments. Every investor will have a slightly different opinion. But over time, looking at all the data we have as a bank, and this isn't doing something like predicting stock prices or something like that, but just looking at what are safe ways that people over time have managed their money. Maybe it's just how they have had them in their funds. Maybe it's moving stuff to like your checking or different types of accounts, suggesting maybe having an RRSP or something like that, and finding over time what really suits your needs. Not making any false promises or anything like that. But really just trying to see for you, if it maybe even for your credit card rewards where you could have made more money over time. And then again, you go to where can machine learning enhance that compared to what if we just calculated all the categories on your credit card and then told you where you could have made money. So for us, it's finding that line of what can we do that machine learning wouldn't be able to do on top of that. So it could even be, instead of having categories on a credit card, actually starting to suggest places that could be categories on your card, but on a merchant level, that you normally wouldn't have in just a category. So just off the top of my head. So then I have this video. How many of you saw the Google Duplex stuff? Cool, a lot of you didn't. So this is a really cool way where Google really is leveraging machine learning. They just announced at their Google I/O event. I actually don't know if I have sound or not, so I hope so. But it's where a subtle way where it's something you would never ever think of even doing as a product manager. But now that I've seen this, it seems like a no-brainer. Or ethically, you might feel really uncomfortable with this. That's the other feedback I've heard.
The promise of the assistant. As I said earlier, our vision for our assistant is to help you get things done. It turns out a big part of getting things done is making a phone call consistent.
Let's get ahead a little bit.
Between 10. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen. That was a real call you just heard. the amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. By the way, when we are done, the assistant can give you a confirmation notification saying your appointment has been taken care of. Let me give you another example. Let's say you want to call a restaurant, but maybe it's a small restaurant which is not easily available to book online. The call actually goes a bit differently than expected. So take a listen.
How may I hear you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people with
Next Wednesday at 6 p.m.
Actually we reserve for like after like the 5 people. For people you can come.
How long is the wait usually to be seated?
For when tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
So these I've just seen going viral online. Obviously, we don't do stuff like this currently at TD Lab, but it's a really, really cool way where they've actually advanced the technology so much that it can actually have a conversation and do these appointments for you. And this falls into a lot of problems that we actually do have with TD, which is getting vendor adoption or buy-in for a certain solution. So with bills, we can't have them conveniently put a QR code so you could scan and pay it. That's something they would never do. But that's the same thing with Google. Some of them won't put ways of ordering online or booking appointments online. Some of them won't go into, even in Google Maps, you actually could have where they can now place an order using skip the dishes or something like that. But a lot of merchants won't do something like that. But when you actually go to their phone channel and you completely automate doing this phone call, it's such this crazy, bizarre idea that I'm sure some engineer, like everyone laughed at there when they pitched something like this. But the fact that they've taken this technology so far and really changed the way that you interface with your phone, especially for myself, I always hate calling to make any appointment or any reservation or anything like that. And I've also been on the other side of that, where I used to work at a Boston Pizza when I was in high school, and I hated taking the phone calls because I found it so hard to understand people sometimes. But the fact that they've trained this agent that is able to understand basically English in such different diverse ways where it can be really broken up and they can still make sense of it is really cool. So if it's sometimes accents are really hard to understand, this agent's been trained on all kinds of different accents to actually understand them just like it's plain English to them. And also when the context changes, the fact it's been able to dynamically change its intention and then still retrieve info for you, not having to basically hang up and then ask you another question and then call back, is completely it's very revolutionary. So ethically they got in a lot of trouble for this, or the people in the service industry were criticizing. So Google has said that they're going to now basically introduce themselves as a bot. You may have noticed that their bot actually added ums and things like that to sound more human. So they took a lot of heat for that. But it's really cool that they're able to pull something like this together. And I think it's just the beginning where machine learning is really going to shape a lot of our interactions that we have. So back to some less exciting content. In our space, a huge part of what we do is based around students. So we actually really go out of our way to hire like hackathon winners and things like that. Students that are really good at hacking stuff together, and they might not know the underlying principles or the theory behind everything, but they might be really good at quickly learning a new technology or something like that. So basically when we pull in all these students, we want to ramp them up for doing machine learning and more of the playful side where they'll look at a Git repo, they'll clone it, and they'll start to tweak it for whatever we're doing and see what we could build. So there's 3 resources I kind of recommend to them when we are ramping them up. It's really hard to introduce students that have never done machine learning to all the principles of machine learning. So for an applied sense, there's 3 books. So the first one is this hands-on machine learning with scikit-learn and TensorFlow. I always say for them to read the first half, which covers kind of fundamental data science and machine learning from an applied side. Then the second one is called Deep Learning with Python. It's actually by the creator of a deep learning library called Keras, this guy named Francois Cholet, and it's really good for high-level deep learning, basically, using this library called Keras. And the third one, if you haven't heard of it, is called Kaggle. So it's an online data science competition platform website where companies post cash prizes. I always say to my students when they come in, don't think that you'll win any money. You have to be very skilled in doing this full time to actually win money on there. But it's really cool because people will actually post their solutions and open them up for anyone to look at. And you can see a lot of really creative things that talented engineers are doing out there that you'd never learn in a textbook. You only really learn by doing and then seeing over time. So I find it to be a really cool resource to see such unique things. So besides just ramping up our students, I talked a little bit about having devs and designers engaged in the development process around machine learning, and I think it's really important to find ways to have everyone work together, as illustrated by this really complicated chart here. But basically what we'll do with our students and our full-time staff every term is a machine learning bootcamp. So we'll go over, I don't know if I put a slide, we'll go over like a toy problem. So we normally do Titanic prediction. So it's predicting if someone survives on the Titanic or not. So it's kind of a hello world to machine learning. It's a really morbid one. But it's a cool one because you deal with so many different concepts of machine learning. So just dealing with text data, dealing with a lot of null values in some fields, dealing with different fields that weren't, like they didn't have computers to enter these things in, so it was a lot of handwritten notes transcribed. But you actually can predict with like 80% accuracy pretty easily just by doing a lot of feature engineering on this data if someone survives or not. So I find it's a really good toy example. And then, so on my next slide. So then also after that, we'll host a Custom Kaggle challenge. So you can actually now on Kaggle for free host your own challenges and have them as invite only. So it's a really kind of fun way in our space for a day to have everyone play with machine learning. So we'll find like some data set online that hasn't been used as much because otherwise people cheat and find the solutions we found. But we'll host this custom competition where basically we have designers and devs and co-ops all form teams and try to get the highest accuracy throughout the day so they can use any resources they want. They can find other challenges, copy and paste that code, tweak it for this. But it's a really cool way to kind of expose people to machine learning that have never even seen it, because they actually get to see the steps that go into feature engineering, to cleaning data, to having stuff in the right format, and to the kind of different features you should be collecting initially to then actually form some sort of accurate model around. And then the big part of it after that is just research and looking at what Google's doing, looking at what Facebook's doing, and even other banks and organizations, and then using it for inspiration, not directly copying it, but seeing how could we do something in an adjacent space that's kind of similar. So this is where the talk's gone technical, non-technical, kind of all over the place. But a lot of our projects we do in our space typically start as this hackathon I talked about. So this is kind of how we do machine learning projects, where then different teams of designers and devs, we might see value in working on a feature on some sort of project or pain point. Designers and devs will typically go and do their own experience. It might be a completely different take on it, but then over time we might find this place when we're running in parallel where we can actually merge the projects. And then what happens, at least like half the time with the machine learning stream, is we actually start with a hypothesis and we realize there actually isn't a correlation, or we actually can't predict this accurately. So before we've committed to actually doing a project, we'll do a lot more of an exploration to kind of validate our hypothesis. And once we validate it, we'll then be able to actually merge with the real project and find ways that we can build something that they can then leverage in their experience. So then we'll typically just bundle it as some sort of endpoint or API that then this other team can work on enhancing or putting into their experience. So then the lab ecosystem, I thought it would be kind of cool to talk a little bit more about our flow, and then mostly the software and how we do benchmarking. So this probably looks similar to a lot of, if any of you work on machine learning stuff, but we do a lot of exploration. Research we spend like a really heavy amount of time on, looking at GitHub, Medium, publications, different software from either open source things or vendor solutions, and basically seeing if it is possible, if it's been done, or if there's something in an adjacent space we can kind of use as a starting point. We'll then do feature engineering, so transforming the data, seeing all the stuff we actually have access to. A lot of the time we actually will build our own data sets in our space, just because we can then we can pick a lot more of the features that we think we'll need from it. And then the fun parts are just the training and the evaluating. And I have these 3 arrows from the evaluating. So we did one project that we spent like 3 weeks exploring, and when we finally finished the training phase and we went to evaluate it, and it was one where we had to do a lot more manual evaluations because we couldn't automate a lot of it. We actually found we had 2% accuracy on the whole project. So it was really, we realized that we should have went way back and started evaluating right away as soon as we could start building a model. Yeah.
So from your experience, how you decide which model to use?
So from what I do, it's very much more of an applied hacker sense. It's not, I don't look at the theory of these different models. I'll typically take 4 or 5, maybe even 8 from, if it's a simple supervised task, from different families of machine learning algorithms. So one gradient boosting one, a random forest one, some sort of SVM, ones from all kinds of different areas. If it's working with data that is a computer vision task or NLP or something like that, we won't look as much at those. We'll go right to different deep learning architectures, but we'll try to just get baselines of a ton of different types of algorithms, and then from the top 3 or 4 candidates, basically start fine-tuning them and see where we get bigger gains to start. And then from that we might have 2 candidate models, and then we'll basically keep using those candidate models and then changing them and seeing if we can get better solutions. So for really supervised things, it's nice when we can do that. Some of our ones that we'll work with will be a lot more complicated to then change the architecture and things like that. Or I'll give an example of for object detection and computer vision, it's basically drawing bounding boxes around people. So one path you can go on is looking at basically convolutional neural networks, but then changing the output mask to just be the segmented mask of where the object is. So that's one path. Another one that's using faster RCNN from Facebook, it does the exact same thing. It'll draw a bounding box, but it trains 3 different deep neural networks to basically propose a region of where they think an object is, then to fine-tune where it is. So there's these really different streams. So it's sometimes not as easy to just plug and play those models and then use those as candidates. But for a lot of our stuff where it might be working with bank data or stuff that is a lot more structured already, it's really easy to just put a ton of models there and then basically get a high-level benchmark of it. And a lot of what we do when we find out we have 2% accuracy is we'll typically go back and then research a lot more and explore where do we go wrong. Is it that there is no correlation at all here and there's some element of randomness so we can't predict it, or is it that we're doing a completely wrong approach to it? So our process is a lot of trial and error, which is good. And in our space, it's a lot more of not giving a hard deadline, which is kind of nice. We have set our own goals, but we have to acknowledge that when we're doing research and a lot more hypothesis-driven development, it could completely change, and we might not make any progress for 3 weeks, or we might complete a project in 3 weeks, depending on the different things we looked into.
So is there any body of knowledge that tells you for a specific domain and type of problem, so it kind of guides you and just have a general question on the web or something, because there is this Kaggle competition,
Yeah.
So sometimes guys come up with some ideas out of the blue, So well, what's drive their intuition to choose a specific model against another one?
So a lot of it, I think, is just intuition and exposure to it, which is a very primitive way when we're being so smart with machine learning. But a lot of it too, we'll look at Kaggle and look at actually competitions that have similar formatted data and then find what people are doing. And a lot of it, just over time, you realize when you're doing computer vision that right now the leading kind of models are convolutional neural nets. And we'll look at variations of those, but we won't look as much outside of those. But if we're working with text data, there's a lot more, or not text data, but just numerical, think of a spreadsheet. It's kind of hard to always know the best model. some models obviously work better on different types of data, but I think if you limit yourself to just thinking you'll know the best algorithm, you might not actually understand the patterns and the nuances of the data. So we really try to have as many diverse models initially from kind of different spaces of the field to get an understanding which ones are performing well without doing any tweaking. This is where Google's AutoML project they're doing kind of falls into place, where they want to train a reinforcement learning agent over time to understand how to define neural network architectures, because there might be patterns in the data that we don't understand. But if a neural network trains, like if one agent keeps building these custom models over time and understands the different types of improvements to make, that maybe there will be some knowledge that it can keep for in the future. And that's kind of what people do with their intuition as well, but they're looking at trying to automate that. Whereas a lot of what we do is very archaic. It's just pulling in a ton of different models. And depending on which library you use, like if it is very clean data, we use like scikit-learn for a lot of explorations. We can easily put 20 models just in a for loop where it goes through training all of them and see what the performance is. But when it's a lot more difficult of a thing, we have to really look at these really different architectures, and sometimes we'll even assign a student to just look at one of them, but they're not allowed to do any feature engineering. We just want to get the baseline without doing any feature engineering. So just finding a way to implement that model on our data and then looking at the baselines that we get. So at least in our experience, this is what's worked best, but it can be really different a lot of the time. And then sometimes we'll like have to resort to ensembling, where we'll have multiple models that people have worked on separately, and then at the end you almost just do an average of their predictions, or you train another model on all their predictions. And the idea of that is you have a ton of weak learners maybe, but if you take the majority rule from that, chances are that will be correct. So if we have a few different adjacent models, some of them will be better at looking at different circumstances and basically having an accurate prediction. So that's where if you train a different model on top of all these other models' predictions, it will actually be able to find, like maybe I'm really good at identifying people on green bikes, and someone else is really good at identifying someone on red bikes, and then someone else also is good at identifying people on red bikes. I might always misidentify people on red bikes. It's a weird example, but if two people, or two of the other models always like are predicting the same thing on the red bikes, we take the majority of that. So the idea that all these people will have little subtle, or the majority overall will have the right answer, which is kind of, again, sounds like an archaic way, but it actually works really well in practice for something like this. So again, like software that we use is all over the place. So a lot of new stuff, but we always go back to TensorFlow, Keras. Spacey is a really cool new library for natural language processing that has a lot more advanced features. Like Word2Vec, you can also do named entity recognition, which is basically if you had like a paragraph of text, having it pull out the entities that are people in it, or organizations, addresses, all kinds of different formats. So you don't have to teach it what a name is. It naturally looks at and understands the lead up to a name and can actually pull that info out for you. And it has a lot of other really cool things in it, where it has pre-trained models and it has really an easy way to train a custom one around that. The first one here is the Microsoft Distributed Machine Learning Toolkit. There's actually one algorithm in it that's really cool called LightGBM. And what that is it's like XGBoost, which wins most of the Kaggle competitions out there. But it has, it's like Microsoft basically rethought it and then made it thread a lot easier. So you can actually train stuff really, really fast, faster than XGBoost in less time than XGBoost. And by having that, you can do a lot more parameter searches and really change the model a lot more. So for quick prototyping, I find it to be a lot faster than something like XGBoost. Obviously, when we're working with really large data, especially within the bank, we'll use Hadoop to access it, and then we'll use Apache Spark in their machine learning library. We do a lot of cool stuff with just Word2Vec and exploring how to build more value from data that we have. We'll build most of our stuff is in Python, so we'll build all of our APIs in Flask. When we're doing computer vision, we'll use OpenCV. Like my favorite tool of all time is definitely Jupyter Notebooks. So it's just like a really cool way of doing exploration, where instead of having your code run in one big, basically block, you have these cells where you can basically load your data in the first cell, and that might take 10-20 minutes depending on the size. Then all of the cells you run below it, you don't have to reload that initial code at the top. whatever you've set the variables of up there, loaded the data into, you can just keep rerunning and tweaking little parts of your code in different cells, and then you don't have to keep running the thing as a whole. So I might have butchered that explanation, but then the other thing that you can see on this picture here, you can actually embed charts. So maybe I just want to run like line of code to make this chart to look at one part of my data, and that'll influence the next thing that I do with my data. I can actually plot that chart in line with whatever I've done, and then I can do a next cell based on that, basically whatever I've seen. So it's a lot more analysis instead of just having to run a code, save the PNG of your plot, go and open it and see what it looks like, go back and tweak. You can just change it and run it all within your, it just runs in your browser, and you can keep going back and forth tweaking little things. So then the last thing I want to talk about, because I've talked about a lot of kind of without project specifics that we've done, but talking about how we evaluate a lot of our environments, especially when we have different people working on the same problem. And I think what's really important is having a unified place where we're logging everything that we're doing and able to look back at what did someone do, look at the actual architecture of the model, and then be able to compare that with everyone else. It's really easy to just keep running things on your own system and then not share those insights, or not be able to go back on a really good model that you had if you didn't push it to a Git repo or log it somewhere. So the biggest thing that we've found is we've kind of gotten the most we could out of TensorBoard. So this only works with deep learning libraries, but basically it comes with TensorFlow, and it's a way of basically logging a lot of your stuff and then being able to visualize it. But what we do is have everyone on our team log their results to this one Git repo and keep pushing that, and then it will just merge everyone's different logs, so then we can look over time at different metrics people have. So here's a little preview of what it looks like. So basically it pulls in all these log files, but then for each of these, so these would be different people's models that they have. You can name them whatever you want. You can actually add notes on whatever they are, and you can actually pick all of the different types of metrics that you want to look at. So you can see, if we were looking at accuracy right here, you can actually see we have all the models selected here, and it will actually plot them all. So for our space, especially if we have students or other engineers working on stuff, they'll put their name with the models, and we can actually see over time who's performing the best. But we can also see maybe it was a really old model actually was doing better than a newer one. So besides just accuracy, you could do validation loss. So I wanted to put a few metrics. So here's loss, where again, it's just two models here. I wanted to make this little note here that in our space, what we actually would do is have a training set of data, a validation set of data for the very end, and then we have a dev set. So that the dev set is our test set while we're developing. But we have found over time it's really good to keep like an extra 10% of your data for only when you think you had a really complete model, to actually then do a final evaluation on that, because we found we were really overfitting to our test data just by manually tweaking different parameters. So it would really improve our test training set that we had during the dev kind of. I don't know if I can do that here. It's cool to actually be able to see what your images look like. So for handwritten digits, it's not as cool, but if you were doing like cats and dogs or something like that, it's cool to actually be able to zoom in and see when something's been misclassified, the group that it's in, and to quickly identify and pull out. Because you might actually be able to see a cluster cat images that were misidentified as dogs, but they might be all in the same group, so you know that there's one circumstance that you need more training data for the cat side of that, or maybe you need to augment your data more. So being able to basically create models and focus just on writing a few things to log all of this has really sped up our workflow, because we don't have to now go and manually plot stuff afterwards. We can have it automatically generate the plots by using the same, we have just like our own logging library for most of the metrics for a project, or we'll build the same library for just a project and we'll share it among everyone. So when you're training your model, you'll be logging the exact same things as everyone else, and then we can go and compare it to everyone else's. And you can actually put custom metrics in here too, and do your own custom plots, which is really cool. And then you can even go and view the architecture of the model and keep zooming in at lower and lower levels and seeing more details of it. So this is all in this tool that Google has bundled basically with TensorFlow. But the really cool thing about it is that there is some other frameworks you can use it with outside of TensorFlow. So Keras, because it runs on TensorFlow, which we mostly use, actually works with it built or natively. But you can actually, someone has this library that works really well. And you can use it with PyTorch, you can use it with Chainer. MXNet, even just raw NumPy if you built something from scratch, but you can actually have all of this logged to TensorBoard, which is really cool. So I kind of just went over a weird mix of everything in our space, but I wanted to really give you guys the perspective from the business side when we're coming up with a problem, the kinds of things that we look at, from a team side, how we work, and then from the software side, what we look at. So in this next time, whatever we have, I'd love to answer any questions you guys have, but otherwise, thank you very much for the opportunity to come down here.
Yeah, you mentioned something just at the very end, the 10%, keeping the 10%. My understanding is you split your training set and your evaluation set. You're suggesting there's now a third set that's additional 10%?
Yeah. So I find like initially, if you then, it depends on how much data you have, but if you have a generous amount, it could be like the percentage doesn't matter, but I think it's important to keep 1/3 set and keep it just for when you actually think you have a complete model to actually then do a final evaluation on. And then the big thing is if you have poor accuracy, don't focus on now changing it and keep evaluating it on this final set. Go back to your test set and try to figure out where it's going wrong and keep evaluating why you overfit to that data. Or maybe you need to go back and figure out how to generalize your model a bit more. So you don't do this iterative process on this final set of data. It's only for doing this final evaluation, and then you need to go back and figure out why you're overfitting on your test set and what you're tweaking that's basically shaped it too much.
Right, so it's just because you don't necessarily have discipline, it's this additional discipline.
Yeah, exactly. And it's because there's, I think people call it the information leak, where we can easily just keep fine tuning a model until it even our normal accuracy might go down, but then the testing accuracy will go up, and you can keep tweaking a model, and eventually you'll get really good test accuracy. But especially if you've ever done a Kaggle competition, you'll learn that you might have a really good test accuracy on your set, but you submit it and they have a different set of data they're evaluating it on, and you might have this huge drop, and it's because you've overfit your model so much to your test data. So Kaggle's a really good place again to look at different distributions or different ways of handling this. And another cool thing you can do is cross-validation. So this is when you train a model maybe 5 different times on 5 different sets of data. So you keep taking different samples to train it on, and then it will test it on different samples. So then when you do that, you end up getting a more generalized prediction, because if you keep tweaking your model, but then it's not as dependent on the crop of data, you just get an idea of how it will appear on new data, and you're not doing as much tweaking that would just work for a certain set of data. So if you search cross-validation, that will come up. Yeah, cool. I think you had a question, or back.
For the exploration phase, how do you guys decide between getting new data or looking at existing data? You don't know what the value is of your outcome, right? So how do you decide what to work on?
So that's a pretty good question. So it depends on the problem, I guess, and we'll always start with just Googling a little bit to see what's been done out there and what data is accessible. So we'll look if there is open government data, third party, even if TD had to buy data from a vendor, or if TD has it in-house. And if we have an idea that, okay, there's a lot of data out there, TD also has this, and then we look at the quality of it, that will typically be kind of what we go off of. Maybe TD does have it, but we only have 4 features that would be kind of relevant. But we found an open set that has 30 features. So in today's world, TD wouldn't be collecting all of that, but in the future we could then shape what we collect and stuff. But this newer set, we'd actually be able to see if there is a correlation between stuff, because if you only have a few features or the data quality really isn't there, it can be really hard to build an accurate model. So the more features you can kind of get, we found, the better. So it kind of depends on what's out there. And then sometimes we'll build our own data set, so it might be scraping online. And then the nice thing about having so many co-ops is you can have them manually label everything for you for a few days. So we use this service called Local Turk. So it's like Amazon Mechanical Turk, but you can just run it locally. So every student gets assigned this many images they have to label or something. And it's a really great way to kind of source your labeling of data. But we don't always do that. We'll mostly try to see what TD has, and a lot of the times we might not have the data. We might be thinking of something that's in such an adjacent space we haven't been collecting it before, and then we'll try to figure out how do we get data like this, because sometimes it might be we could dynamically change the app to present you this sort of thing, But if we don't have data on how people interact with the app, we can't really like simulate that or get that as easily. So some things we never really get the chance to look into just because it hasn't been logged, but we'd be the only ones that could do it. Yeah. Yep.
How do you, if at all, deal with ethics in your algorithm and kind of the creepy factor of calling someone and say, hey, I've looked at your bank bill. Looks like you're having some car trouble.
Yeah. So we deal with this a lot because especially in our space, we try to do stuff that is more focused on the customer experience. Like we don't deal with the fees or we don't have to deal with percentages or anything like that, even our business cases, which is really great. We're not as judged on like the profit of our thing. So our idea is we try to focus on just building a better experience, and most of the time that's not like ethically invading someone's space. But for circumstances like how do we offer a mortgage or say auto insurance or pre-approving you for a loan without it being creepy that we've been monitoring your transactions and things like that. So I don't know if there's a great answer to this. It's like different for everything. Most of the time it's just coming up with a few ways and actually going and testing on people. So actually giving them the app and then interviewing them on how they feel about things and seeing the things that are less creepy to them, taking that, exploring maybe 3 more variations of that and seeing if we can kind of through this iterative process improve that. There is a lot of like things that otherwise like you can easily spin it like we know you have a car, we know you have car problems, we want to offer you this. So there's definitely like it's just finding that way of spinning it, and it's hard to figure out what the best way is for general people because I'm kind of cool with giving a lot of my data if it's a better service, but I don't share that with everyone. And a lot of our customers are like tinfoil heads and things like that don't want their data used for something like that. And I think that a lot of like banks and organizations as a whole are now looking at more opt-out policies. So if you don't want to be analyzed, it's kind of like Facebook has more ways of you opting out of tailored ads. I think this is like the political side I don't like interact with and stuff, but I think as a whole in Canada they're looking at doing more things that are opt-in, opt-out nature. And then it's the same with like Facebook offering you ads based on your like search history and things like that. Obviously Facebook is in a bad place right now, but before I didn't really find tailored ads that creepy or anything like that. I do prefer them over ads that are really irrelevant. So I think it's just figuring out, like I think that our customers as well might get annoyed if you're like 70 and we're offering you like a student loan or something that's not tailored to you at all. But if we can actually tailor something that makes sense, and I think making sure that what we're doing is accurate and actually brings value. So even if maybe there is this creepy factor, if it actually brings real value to you, maybe it's a bit better to do that then, and maybe people will let it slide. But I think a lot of it, like I can make assumptions, but I think it's just going and testing on a large pool of people for whatever our target demographic is. Yeah.
Do you use any of your ML techniques to test the labeling itself?
So it's kind of like a more like manual thing. So we'll do like clustering a lot of the time to figure out if it's like computer vision or even like which samples are being misidentified. And then a lot of the time you can actually manually review if it was something that was mislabeled. So this happens a lot with like third-party data or open data, whereas internally most of the stuff that we have is like pretty accurately collected. I find that it's easier just to look at why are you misclassifying some things and seeing if there's a pattern in those and manually reviewing, like even if it's 100 examples of ones that have been misclassified, you can generally get a good idea why it's misclassifying something, and maybe you need more samples of that kind of case, or maybe it's the data itself just needs to be thrown out. So this works like well if you have a pretty good model but there's still problems. Obviously if it's like you have a really like bad model and you can't identify like 500,000 records, we might look at clustering or something to kind of see if there is, and putting the classes we have, and then you could see if there's these subclasses or something that maybe aren't identified or captured, but kind of better depict the data, and then we could try to build a model around these clustered labels or something like that. So we haven't like done as much of that. It's mostly because of the size of what we sometimes work with, we're able to manually review, which is really nice and get a better understanding. But we've had it like before, just resort to clustering, and we have like no idea why it's not working well, and just hope that we can find it. And a lot of the time, that actually works really well. So,
cool.
Yeah.
So how you seem to be more like an R&D space, where you're just rapidly iterating on anything, throwing everything at the wall and see what sticks. How long, on average, would your projects be? Like,
So
You mentioned 3 weeks a couple times.
yeah, so I try to like aim for like, because we're doing a lot more R&D stuff, like 1 month for machine learning one, if it's just testing a hypothesis and that, because a lot of what we do isn't building the actual experience. We'll work with designers and that to kind of figure out the input that we want to predict with the model. But if we can wrap up kind of our iteration around the actual machine learning model side, we'll then give it to another team. So it might take us a month, but then for them to build the experience that might adopt that can, like, we try to aim for like 2 months. So every 4 months with our co-op terms, we can do like 2 projects. But sometimes it'll end up being all 4 months depending on what it is. And sometimes for the machine learning side, like the one that we had 2% accuracy, that ended up taking 3 months with a student that we had. Just because when we started going back, we realized we really need to re-explore. And then if we had done another full exploration and still only got, let's say like 20 or 30% data, or accuracy, we probably would have just like scrapped that project and said there isn't a correlation here. We can't hack one out of it. But it really, like in our space, it's kind of nice because we have a lot of freedom with the deadlines, because it's a lot more like if we build an app and people don't like it, we need to change the app. It's not like we're just going to ship it anyways. And sometimes we might think we know best, but when you actually test on people, you get really different feedback. So it changes a lot. But with the machine learning stuff, I think it's like depending on the format of the data, but if we have it all, it's pretty realistic in a month with a few people to be able to get some models with pretty good accuracy out, and otherwise find a way to either pivot or scrap that altogether and start looking at something else. It depends on like your capacity, the size of your team, and then I think like the amount that you have to clean your data or collect your data, because that itself could take weeks just to pull all of that in. So
Yeah, that was actually leading to my follow-up question. Is so do you think that a large percentage of your time is cleaning up the data? Is my understanding with machine learning. So would you say that your percentage of the time allocated to different tasks would be different than someone who wasn't doing a rapid prototype sort of scenario?
Yeah, it definitely changes a lot, because even when people are like our devs that rapid prototype, they can do screen mockups and then go and test that right away. Where for us, we don't even know the format of the data, what we can pull in to start. And really, jump back to for this, we probably spend 20% of our time exploring, 30% of our time, let me see. Most of our time is spent on the feature engineering, the research and exploring, at least 70, and probably 30% of our time is spent on training and evaluating. And just because we have to go back so many more times and research more and do a lot more of the feature engineering, the actual training of models can be pretty fast, because you can optimize parameters in a pretty brute force way where you might need to leave them for a few days training a ton of models. But that's really easy to automate, where the feature engineering and the exploring the data, the cleaning it, that takes a lot of time, and even figuring out, forming what we would need to actually predict something, and then especially if we found there's no correlation, going back and trying to evaluate where did we go wrong, are we using the wrong type of algorithms, or do we need to have a completely different set of data. So I'd say that most of the time is spent on the feature engineering and the research and really getting an understanding of the data. Even the domain that we're working on, sometimes you don't have to know a lot about it, but sometimes you really need to understand why are loans approved, and what are the criteria that a bank would judge approving a loan on, to actually be able to go back and look at the data, see the quality of it. So understanding the domain is a lot of the research as well, because none of us come from a bank background in our space. So it's working with the team within the bank, because they might have insights for us, and really your professionals in that field, and then looking out online and kind of what people talk about there, and then studies that have been done around that space, because it's really it's great for Kaggle. You can do lung cancer identification without being a doctor, just by brute forcing a lot. But for a lot of these things to actually evaluate the quality of the data, you have to work with professionals in that field, I think. That answers your question.
Yeah, it's a great thing.
Awesome. Cool. Well, thank you very much for your time, and I hope you kind of got something from some part of this. And yeah, I'll see you guys around.
Thanks, Jackson. All right, well, thanks everybody for coming out tonight. We may or may not have one more. We're not quite sure yet before we break for the summer, so just watch your email.
Okay,
I forgot that you had moved, and then I
Oh, thank you very much.